Hi everyone, we're going to find the x values, if any, at which f is not continuous, and which of the discontinuities are removable. And these are piecewise defined functions, and we're doing 4 of them. And the first one we have is this one here, and what we first are going to notice that this f function has a possible discontinuity at x equals 1. So possible discontinuity, and I can't write very well. I'll just put discontinuity at x equals 1. We're looking at this number here. And so what we're going to do is we're going to try 1. So we're going to plug in f of 1. So that means it goes into this first piece, because that's where x equals 1. And that equals 1. And then we're going to take the limit as x approaches 1 from the left, that means less than 1, and see if it equals, let me put f of x here, see if it equals the limit as x approaches 1 from the right. That means the positive values. And when you plug in 1 in both of these functions here, you get 1. So the limit, the left side and the right side limits are the same. So f of 1 in general, since they're the same, equals, is the same, so f of x equals 1. So that means f is continuous at x equals 1, so f is continuous for all real numbers x. Alright, and the next one, we're going to do the same procedure. We have a possible discontinuity at x equals 1. So we're going to first try f of 1, and at f of 1, that means we're plugging it in this one, we get 1, and if we try our limits, we're going to take the limit as x approaches 1 from the right, which we already got was 1. All numbers bigger than 1, the right side of f of x. And see if it equals the limit as x approaches 1 from the left. And that f of x is actually negative 2x plus 3. And when you plug in 1 into this equation, you also get 1. So basically, the limits do equal, and so the limit f of 1 equals the limit as x approaches 1 from the left and the right of f of x. So it is continuous at x equals 1. So f is continuous for all real numbers x. So once the right side and the left side equal, then it's continuous. Okay, now this one has a possible discontinuity at x equals 2. So basically we're going to check first f of 2, which would be the first one here. When you plug in 2 in here, you get 2. Let's see, where am I? So that's going to equal 2. And now let's check to see if the limits from the right and left match. We know the limit as x approaches 2 from the left of f of x, that equals the limit as x approaches 2 from the left of equals 2. This is 1/2 x plus 1. We already know that that equals 2. And we also want to do it from the right. And that is 3 minus x. And that equals 1. Okay, so therefore the limit as x approaches 2 in general of f of x does not exist. Therefore f has a non-removable discontinuity at x equals 2. And the last one we have the same kind of thing, so we're going to check first if we have a possible discontinuity at x equals 2. And so what I'm going to do is just my first step is to check f of 2. That would go in this first one here. So f of 2 is -4. And then we're going to check for the limits, left side and the right side. So for number 2, we're checking the limit as x approaches 2 from the left of f of x, which equals the limit as x approaches 2 from the left of -2x, which we already know is -4. These are all numbers less than 2. And then we're also going to do the limit as x approaches 2 from the right side. And that's going to be x squared minus 4x plus 1. And that equals -3. Since these limits, the right side and the left side don't match, the limit as x approaches 2 in general of f of x does not exist. I'll just put D and E. Therefore, f has a removable discontinuity at x equals 2, right here. Okay, the next set I'm going to do involves trig functions. Thank you. Have a nice day. Bye-bye.